subjective experience feels continuous, a single, unbroken stream of identity. Yet the neurological substrate beneath is composed of rapidly changing, chaotic internal states. This raises a fundamental question of maintenance. What mechanism prevents the mind from fragmenting into static as we transition between different thoughts or disjointed dream scenes? Traditional analysis often treats these transitions as random neurological noise, the byproduct of a system idling during sleep. Modern dynamical systems theory offers a different perspective, searching for a hidden mathematical structure that preserves coherence during these shifts. Analyzing consciousness as a physical environment governed by topological rules allows us to measure how the mind maintains itself. This framework relies on two complementary models. First is continuity theory, or CT, the layered boundaries allowing a mental unit to persist as one thing. Second is the Brain Kinematics Model, mapping how neural flows drive transitions through those layers. Dreams offer a unique laboratory for this model because they reduce external constraints, exposing the brain's raw internal navigation. We can see these dynamics in a documented case study, a dream where a subject struggles with city navigation, visits a central mosque, and experiences an intense emotional release of grief. By deconstructing the spatial and emotional shifts in this sequence, we can identify the physical principles that organize the movement of human thought. Experience functions as a hierarchy of 6 interacting layers. A disturbance at the base propagates upward. Levels 1 and 2 are the physical and tissue layers, the domain of basic electrochemical activation, and the brain's viscoelastic substrate. Levels 3 and 4, the network and cognitive layers, are where raw activity is organized into functional memory indexing and associative routing. The structure is capped by the emotional and symbolic layers, assigning value, narrative identity, and cultural meaning to the layers below. In our dream study, the subject's search through city alleys represents the cognitive layer, while the mosque serves as a stabilizing anchor in the symbolic layer. Continuity theory maintains the coherence of these levels, ensuring the experience remains one dream, even as activity shifts violently between the alleys and the mosque. We can track the mind's movement through these layers on a 3D phase space, defined by axes of coherence, strain intensity, and flow stability. Every mental state occupies a specific coordinate here. Focused waking thought sits in a high coherence zone, while fragmented dreaming occupies a much less stable region. Early in the dream, the subject is lost in a city, receiving unclear directions and experiencing rising frustration. We plot this as a state of high strain and low coherence. The brain is working hard to orient itself, but failing to find a stable path. The dreamer then attempts to fly above a crowd, which triggers self-consciousness and a feeling of social exposure. This shift increases the flow variable, creating mental turbulence that pushes the system further away from its balance axis and toward an overload state. Within this model, mental stress represents a literal, measurable distance from a state of topological equilibrium. The brain attempts to resolve this distance and return to balance using the relational navigation equation. In the dream, the subject cannot find their intended educational destination. When this primary goal fails, the brain seeks a secondary route to lower the mounting strain. It uses the M of X, the memory term. The mind begins routing the search through familiar, related anchors, such as the dreamer attempting to find the school by first locating their aunt's house. When local routing proves insufficient, the A of X, the attractor term, takes over. Large-scale topological magnets pull the mental state toward a high-coherence center. This massive mathematical attractor manifests in the dream as the sudden arrival at the central square and the mosque. These transitions suggest that dreams are not random reels, but computable navigation processes seeking a stable resolution. The parameters governing this balance are organized fractally. A single global strain branches into smaller, nested fields like navigation, social exposure, and attachment. As the dreamer enters the mosque, they see their father's belongings on a wall and begin crying intensely for their mother. When surface-level cognitive strain remains unresolved, the system collapses vertically into the deepest layers of the fractal tree. These deep layers are origin attractors, For the human brain, family and home serve as the final grounding mechanism when higher-level navigation fails. Crying in the dream functions as a physical release. It is a rapid discharge of strain to bring the system back to a neutral state. These emotional climaxes represent the system executing a topological reset to clear the strain it couldn't solve through logic or movement. This navigation process isn't limited to the dream state. Research into the hippocampus shows that the same grid and place cells we use to map a city are recycled to navigate conceptual spaces, like language or logic. This table illustrates the functional bridge between physical and mental domains. In the BKM framework, the energy of a physical system is effectively mapped to strain in the mental domain. Similarly, physical momentum reflects the rate and direction of neural flow. Just as mass concentration creates a gravity well that pulls a physical object, dense memory structures create attractors that pull a stream of thought. Navigating a physical street and navigating a symbolic proof appear to be the same thermodynamic process occurring across different layers of experience. If our thoughts are effectively a form of relational navigation, we have to reevaluate the role of human feelings. Within the kinematics framework, emotions serve as the subjective readout of our position and velocity within the brain's strain landscape. This infographic shows the relationship. Anxiety is the subjective indicator of high strain and low coherence. Relief is the readout of a decreasing strain gradient. The continuity of consciousness is a product of this constant mathematical coordination of internal chaos. From the logic of our waking lives to the deep grief of our dreams, our minds are perpetually seeking a path back to topological balance.